In the modern day search for better energy to power our homes and lives, many different sources have been used. There's oil and coal, wind, and nuclear. All of these have drawbacks. Oil and coal will soon run out, windmills only work when there's a breeze, and nuclear isn't always user-friendly. A safe, clean, and fairly reliable form of energy is solar. A photovoltaic or solar cell allows a photon from the sun's rays to excite an electron from a non-metal side of the electron then travels through a circuit, providing energy for what's needed before returning to where it started. Because it's powered by the sun, solar cells are always able to work, except when it's cloudy or night. Okay, they do alright in the clouds too. In order to make solar cells more worthwhile and cost-effective, my experiment looks into the variables that affect the output of a solar cell, the frequency and intensity of light on the panel as well as the environmental temperature, and see what relationship they share with the cell. My hypotheses were that a higher intensity of light would have a greater output, that a yellow filter would have greater output, and an increase in temperature would have a decreased output. For this experiment, I set up a lamp on a stand at the end of a track to serve as an artificial sun, and set the solar cell up on a movable stand and hooked it up to a multimeter to record the voltage and current the cell took in. A shroud was placed around the cell to reduce the effects of background light. To change the frequency, a different color filter was placed in the stand between the cell and the light for each round of data collection. To measure for intensity, a lux meter was placed with its sensor just below the cell. A temperature probe connected to Data Studio measured the environmental temperature, while a heat lamp would be used between rounds of data collecting to increase this temperature. Once the overhead lights were off, I recorded the data from the multimeter with each variable having a chance to be measured as an independent variable. My results varied. I was correct in my hypothesis of increased intensity of light causing increased output. My hypothesis regarding frequency could not be proved because the darker colors required the cell to be closer to the light than the lighter colors in order to have a constant intensity. The inverse square law took an effect, meaning the darker and closer colors gave much higher results due to their closeness with the cell. As for temperature, the output decreased steadily for some time, but between 45 and 55 degrees Celsius, the current increased while the voltage decreased with each trial. This anomaly increased the overall power. In future testing, I would like to find a way to remove the distance variable from the frequency trials. For temperature, I want to know if this anomaly continues beyond 55 degrees Celsius, and if something similar occurs below 25 degrees Celsius.